Hello everybody. I'm going to continue on with chapter 8. I know that the last problem that I solved was problem number 23, which is on page 327 for 11th edition users and page 361 for 12th edition users and page 367 for 13th edition users. This is problem number 23 out of chapter 8. We already did this in the previous video. I think that was number 5. Excuse me. But I think according to some of you guys' email, I think I've made a mistake on problem number 10. I haven't actually gone back and take a look at what I did in the video. I'll just go ahead and do problem number 10 one more time. Problem number 10 out of chapter 8, which is on page 315 for 11th edition users, page 349 for 12th edition users, and page 355 for 13th edition users. So problem number 15, you go ahead and read the problem, and part A, they want us to do %90 confidence interval of estimate of the population mean. So these are the, this is the sigma known case. Population mean, this is number 10, problem number 10. So mu is equal to 119,155. Yep. And then the sample is n is equal to 80. And let's see. Standard deviation is 30,000. Sigma is equal to 30,000. Okay. So develop part A 90%, or part A 90%. So for this, Z sub alpha over 2 is equal to 1.645. So we have x bar plus or minus. I don't want to be blocking your way here. Plus or minus z sub alpha over 2 times sigma over square root of n. Okay? And x bar 119,155 plus or minus 1.645 times sigma, which is 30,000, divided by square root of n, which is 80. So this is 119,155 plus or minus. This is 5517. So 5517. So you add and subtract this to this value. That is going to give you the range. Then we say that we are 90% sure. We are 90% sure that our population mean is going to be within this range. This is for part A. For part B, they ask for 95%. They ask for 95%. So for part B, for 95%, z sub alpha over 2 is 1.96. This is the formula. This plus or minus 1.96 times this divided by this. And then the answer is, for margin of error, is 6574. 6574. So you add and subtract to this, and that is going to give you the range. And we say we are 95%. We say we are 95% sure that our population mean is going to be within that range. And then for 99%, part C, this is part C. That is 2.576. 2.576 plus or minus 8640 plus or minus 8640. This is for part C. And then for part D, they're talking about discuss what happens to the width of the confidence interval as the confidence level is increased. Does this result seem reasonable? Explain. Well, when we increase the confidence interval, we are also increasing the margin of error. When the confidence level is, like in this case, it is 99%, and margin of error came out to be 8640. When it was 90%, margin of error was 5517. And this result is reasonable because when you are going to take a bigger chance, then you're going to have a larger possibility of making error. So that's for problem number 10, that someone said I probably had made a mistake, and probably they are right. And now we're going to continue on with chapter 8. The last problem that I did was problem number 23 on chapter 8. And this was about determining the sample size. Determining the sample size. This is to refresh you guys' memories about where we left off, when n is the sample size is equal to z sub alpha over 2 squared divided by, multiplied by sigma squared divided by e squared. So this is where we left off, and we're going to leave it there. And now we're going to continue on with chapter 8. Continuation of chapter 8 starts with the interval estimation of a population proportion. Again, to refresh you guys' memories about the population proportion. First, talking about a proportion. Proportion is fraction of the population or sample fraction of the population or sample with the characteristic of interest. With the characteristic of interest. Example, we have 100 students, and I ask these 100 students as my population, I ask them how many of them are willing to or would like to apply for graduate school upon their graduation. Let's say that out of 100, 80 say that they would like to do that. So 80 divided by 100 is going to be population proportion. If I take a sample of 20 students from this 100, then I ask the same question from those 20 students. How many of you guys would like to apply for graduate school? Let's say that out of 20, 15 say that they would like to go ahead and apply for graduate school. So 15 divided by 20, that is going to be the sample proportion. All right? Now, this part of chapter 8, we're going to do everything that we did with X bar, whatever that we did with X bar, like we had X bar plus or minus Z sub alpha over 2 times sigma over square root of n. This was for sigma known. Now we do exact same thing, but this time for proportion. We say population proportion, this is population proportion, plus or minus margin of error for the population proportion, which is going to be Z sub alpha over 2 times square root of P bar times 1 minus P bar divided by N. So everything else is going to stay the same. What do I mean by everything else? We're going to use the Z table to find the Z sub alpha over 2. We have 90%, 95%, 99%, or we could have 80%, 85%, or 70, whatever percentage for the confidence interval. And, excuse me, calculation of the range is the same. We go ahead and calculate this margin of error. We add and subtract it to and from population proportion. I'm sorry, this is sample proportion. I'm sorry. So we add and subtract it to the sample proportion. This is sample mean, this is sample proportion. And then we say we are, let's say if we did 95% confidence interval, we say that we are 95% confident, or we are 95% sure that our population proportion is going to be within this range of our sample proportion. We say we are 95% sure or confident that our population proportion is going to be within this range of our sample proportion. The only difference is that for the margin of error, we are using this formula instead of sigma over square root of n. This is for infinite population. When we are dealing with finite population, then this is for infinite population plus or minus Z sub alpha over 2 times sigma over square root of times the square root of P bar 1 minus P bar divided by N times square root of large N minus a small n and large N minus 1, if you guys remember. This is for finite population. All right? If you go to slide number 36 of the old PowerPoint, there's an example that starts on slide number 37. I want you to please read the slide. And then they say that they found that 220 registered voters out of 500. So this is the proportion. This is the sample proportion, which is 220 divided by 500. That will give us our lowercase p bar. So without going any further, right in here, I will do, this is slide number 38 on the old PowerPoint. So sample proportion is equal to x divided by n. So x is 220 divided by 500. That's, I think it's 0.44. And now we have to go ahead and calculate the 95% level margin of error. All right? So we go ahead and do 0.44. Well, here's the formula. P bar plus or minus z sub alpha over 2 times square root of p bar 1 minus p bar divided by n, 0.44. This is our lowercase p bar. Plus or minus, for 95% we have 1.96 times 0.44 times 1 minus 0.44 divided by n, which is 500. This is on slide number 39, old PowerPoint. This is an example in the PowerPoint slides. So 0.44 plus or minus 0.0435. 0.0435. So we add and subtract this to this. We have a range, then we say we are 95% sure that our population proportion is going to be within that range. I just noticed that on the slide, 0.44 plus or minus, they are missing the minus right there. So that's a little mistake on the PowerPoint slide. And if we are going to find, we're not going to touch this part. So they're talking about on slide number 40, they're talking about determining the sample size when we only dealing with the population proportion and sample proportion. So we're not going to cover that. This is going to be the end of the chapter 8 material. So we're going to go ahead and solve some problems for this part of chapter 8. Let's see, problem number 31. Problem number 31 and 36. We're going to do problem number 31 and 36. For 11th edition users, page 331. For 12th edition users, page 365. For 13th edition users, page 372. So problem number 31. I'm going to do problem number 31. Okay, number 31, chapter 8. Part A, sample of, they say, n is equal to 400. 100 yes response. So we can say x is equal to 100. What is the point estimate of the proportion of the population that would provide yes response? So in this case, they just want us to go ahead and find the point estimate. Means, if you remember, this is the point estimate for this. So that's what they mean. So we have to find point estimate, which is x divided by n. So x is 100 divided by n, which is 400. This is the sample proportion. A fraction of a sample or population with the characteristic of interest. Sorry. The point estimate of what is the characteristic of interest? Those who answered yes. Those who provided yes for answer. So this is going to be 0.25. This is for part A. For part B, what is your estimate of the standard error? Standard error is sigma sub p bar. Okay? That is equal to p bar times 1 minus p bar divided by n. So that is square root of 0.25 times 1 minus, I'm going to continue down here, 0.25 times 1 minus 0.25 divided by n, which is 400. So that comes out to be 0.0217. 0.0217. 0.0217. This is for part B. For part C, compute the 95% confidence interval for the population proportion. Okay? So we do part C over here. Part C, P bar plus or minus Z sub alpha over 2 times P bar times 1 minus P bar divided by N. So if you look, we already calculated that sigma sub P bar, which is this one. This is this, all right? And then P bar 0.25 plus or minus. For 95%, we have Z sub alpha over to 1.96 times this, which is 0.0217. All right? And this comes out to be 0.25 plus or minus. I'm going to erase this part. 0.25 plus or minus 0.0424. So we are 95% sure that our population proportion is going to be within this range when we add and subtract this to and from 0.25. Problem number 36. According to a statistic reported on CNBC, a surprising number of motor vehicles are not covered by insurance. Sample results consistent with the CNBC report showed that 46 of 200 vehicles were not covered by insurance. Again, the sample proportion, a fraction of the sample, in this case, 46 out of 200, characteristic of interest, those who are not covered by insurance. Part A. What is the point estimator of the proportion of vehicle not covered by the insurance? Number 36. Part A. We have x equal to 46 and n equal to, did I say 200? 200. So proportion, the point estimate of the proportion is equal to 46 divided by 200. That is equal to 0.23. Part B. Develop a 95% confidence interval for the population proportion. So lowercase p bar plus or minus z sub alpha over 2 times square root of p bar 1 minus p bar divided by n. P bar is 0.23.